How's it going? Hmm. Alright, I hope everyone's doing okay today. We're just going to look at the review problems for test 2. So I will go ahead and start on those now. Alright, so problem 1. Suppose we have a small bag of jelly beans. The bag contains 40 red jelly beans, 33 blue, and 27 purple. Remember that's actually 100 total if we add those together. Two jelly beans are selected from the bag at random without replacement. Find the following probabilities. A, we select 2 purple jelly beans. B, the first is purple and the second is red. Okay. So we talk about the probability of choosing 2 purple jelly beans. And again, we're not replacing the jelly beans. That means when we take one jelly bean out of the bag, there will now be one less. So for our first purple jelly bean, we know that there are 27 purple jelly beans in the bag out of 100 total. And the second one, if we got a purple the first time, which that's what we want to get according to this event, if we get a purple the first time, that means now there's 26 of the original 27 left and 99 of the 100 jelly beans left. So it'll be 26 out of 99. And so from here, we just multiply those together. Now, when we multiply fractions, we're going to multiply across the top and across the bottom. So 27 times 26 on top. It's 602. And 100 times 99 on the bottom. Actually, no, sorry, that would be 702, not 6. My bad. And then 9900 on the bottom. So we'll take 702 and then divide by 9900. And we get 0.071 if we round to 3 decimal places. Now, this problem will be a fill-in-the-blank problem where you enter your number. And this is something I ran into with my... it may have been on in this test, last time I graded, in test 1. It may have been my college algebra class. Anyway, what I ran into is that on the fill-in-the-blank problems, we just have to make sure that we don't put any extra spaces here. And I'm going to put in the instructions that all decimal answers should be rounded to 3 places. So if you put more than 3 places, there's a chance you're going to get it wrong, even though your number is right. Because that's going to be set up to grade automatically by the quiz tool in Canvas. And basically I have to enter in the possible solutions from there. So we want to make sure we pay attention to the instructions and enter the numbers correctly. That way the grading tool will actually count them correct rather than incorrect. Okay. Now part B we want is 1 purple jelly bean and then 1 red. And actually the order is not important. We can do them in any order. As long as we're getting 1 purple and 1 red, the probability will be the same, even though it may not look like it. Alright, so 1 purple, we already know for the first one, that probability is 27 out of 100. And for the second one, if we want to get 1 red one on our second draw, there's 40 red jelly beans out of the 99 that are now remaining. Okay. So multiply across 27 times 40, which I believe is 1080. 100 times 99, which is 9900. So we take 1080 divided by 9900. And so that gives us 0.109. Okay. So that's problem 1. We'll move ahead to problem 2. Alright, suppose you bought a digital album from your favorite artist and set iTunes to play the album in random order without repeats, which again is without replacement. The album has 11 songs, and it turns out you really like 7 of them. Find the following probabilities for the first 2 songs played at random. This is actually a lot like the jelly bean problem. Even if it doesn't look like it necessarily, the concept is the same. We have 11 songs. Of those 11 songs, we like 7. And 4 that we maybe don't like as much. Okay. So if we want to look at the probability that we like both of the songs, okay, for the first one, again, it's like we have 11 total jelly beans, 7 are one color and 4 of another color. That's really what's happening here. It looks like a very different problem, but it's actually very similar. For the first song, assuming that we're going to like both of these songs, there's a 7 out of 11 chance. 7 songs we like out of 11 total. So 7 out of 11 chance we like the first song. And then for the second song, since the playlist is set up to not repeat, that means there's a six songs left that we like out of the 10 songs remaining. Okay. And again, we just multiply across. 7 times 6 is 42. 11 times 10 is 110. And then taking 42 divided by 110. That gives us 0.382 if we round to 3 decimal places. Okay. Part B, what is the probability that we do not like either of the two songs? Well, if the playlist ends up picking songs that we dislike, there's 4 in 11 chance that we dislike the first song. And if we already played one of the songs that we don't like, and then the second song it plays, it'll be 3 out of the remaining 10 that we still dislike. We multiply across. 4 times 3 is 12. 11 times 10 is 110. And so 12 divided by 110. So that'll be 0.109. Okay. Now part C, this one's a little bit different than what we saw in problem 1. Part C is, what is the probability we like at least one of the two songs that are played? Okay. Now the probability that we like at least one, this goes back to our discussion on complementary probability. With complementary probability, we know that the probability of an event is equal to 1 minus the probability of that event's complement. So what is the complement of liking at least one? Well, the opposite of liking at least one of the two songs is that we like neither of the songs. Okay. Now, we've already calculated the probability that we like none of the songs. That was actually what we found in part B, and that was 0.109. So all we have to do here is subtract, and we end up with that will be 891 as our probability. Okay. So we can use the complement in this problem to help us calculate this outcome much more easily. Normally what we'd have to do is we'd have to look at the probability that we like exactly 1, and we have to calculate whether that's the first one or the second one, so it's two different calculations there. And we have to include the possibility that we like both, so that's the third calculation, although we already did that in part A. So we'd have to do those three different calculations and add them together. So the much easier route is to use complementary probability here and say, well, if we don't like at least one, that means we didn't like either one. Okay. And so we can use that to our advantage using this complementary probability formula. And so we took probability of none, that was our result from part B, and we just filled that number and subtracted from 1, and that was our answer. Okay. Alright, so for problem 3, we have a table. Let's see. Just filling in the values here. Alright, so a department store has three colors of appliances: stainless steel, black, and white. The table shows the number available of each type for, in this case, refrigerators and dishwashers. So we have 25 of each of the varying colors. Alright. So we'll use this table to answer the, looks like 5 questions that go with problem 3. A, what's the probability that we select a dishwasher if we choose an appliance at random? Well, we just look at the number of dishwashers, which is 25, out of the total number of appliances, which is 50. It's just 25 over 50, or 0.5. So B, what is the probability that an appliance selected at random is stainless steel colored? Well, if it's stainless steel, we know there's 24 of those appliances in total, or that color, or have that finish, I guess we should say. Haley, I will set it up to accept both answers. Whether you put the 0 in front or not, it won't make a difference. Yeah, that much at least I will set up for it to accept. But, again, don't go past 3 decimal places, because then that'll... I mean, I can go back in and change it if it's correct and it gets counted wrong because of something like that, but it may not catch it, always. Okay? And that's the danger. 24 stainless steel colored appliances out of the 50. So 24 out of 50 is 0.9, no, 0.48. 48? Yes. Alright, problem C. The probability that an appliance is both white and a dishwasher. Okay. So basically we're looking for the number of appliances that meet both requirements. So we have our column on white colored appliances. Dishwashers is here. So we look where those two overlap, and they'll be right here at the 2. So there's 2 of them that are both white and dishwashers. 2 out of the 50 total. So that'll be 0.04. Alright. Probability that a randomly selected appliance is either stainless steel in color or a refrigerator. Now, with our OR statement, we have to use our addition rule, which is the probability that it is stainless steel plus the probability that it's a fridge minus the probability of both occurring. Okay. Now the probability of the stainless, we already calculated that. That's 24 over 50. I'm going to leave it as a fraction here. For choosing a refrigerator at random, the refrigerators, we know that we have 25 total out of 50. And then for the probability that an appliance meets both requirements, that is stainless steel in color and a refrigerator, stainless steel, refrigerator, those meet right here. So there's 13 appliances that fit both requirements. So subtract 13. So 24 that was interesting. 36 out of 50, which is 0.72. Sorry about that. Give me a second.